Now, fundamental theorem of integral calculus. You have done the fundamental theorem?
Good morning, sir.
Good morning.
Yes, sir.
Fundamental theorem of integral calculus. Now, very simple example of fundamental theorem. Suppose if I give you an integral 0 to 1 x square dx. How do you evaluate this integral? If you use fundamental theorem, what you were doing was you were taking 1/3. You were evaluating this as an indefinite integral first, right? So I say we have evaluated it as an indefinite integral x squared dx, which will give you x cubed by 3, right? Isn't it? Plus c. Now, if you want to evaluate with the limits, therefore integral 0 to 1 x squared dx was this x cubed by 3 evaluated between 0 to 1. Remember this?
Yes, sir.
So what are we doing? We are putting the upper limit first and the lower limit next, right? This was the fundamental theorem
Yes, sir.
of integral calculus that we have already done. We have done the applications also. Okay. Now, what happens in substitution? Suppose if we are given an integral to evaluate where you have to substitute, then and it is a definite integral. Then what do you do? Let us take an example in this regard. Let us say that the problem here is evaluate integral 0 to 1 sin inverse x by root 1 minus x square dx. Suppose this is your problem given. How will you evaluate this integral? Can you tell me how to evaluate this integral? How to evaluate this? Yes, Govinda, where are you? Lot of background noise. You know that the derivative of sin inverse x is 1 by root 1 minus x square, right? So we evaluate this first as an indefinite integral. So we have I is equal to integral sin inverse x by root 1 minus x square dx. You evaluate this as an indefinite integral first, isn't it? That is how you have been doing. What you do here is
Yes, sir.
put t is equal to sin inverse x. Therefore, what do you get? You get dt dx is equal to 1 by root 1 minus x square. That means you get dt is equal to dx by root 1 minus x square, right? This is what you will do when you are evaluating this as an indefinite integral. You will do this by substitution. Therefore, what does I become? I becomes integral t for sin inverse x, and dx by root 1 minus x square becomes dt. So this simply becomes t dt integral. And what is the integral of t dt? Half of t square plus c. Now I put back the value. What is the value of t? Sin inverse x. That means half sin inverse x square plus c. Right? Now we move on to now we'll use the fundamental theorem to evaluate this definite integral. Therefore, integral 0 to 1 sin inverse x by root 1 minus x square dx is equal to half sin inverse x square evaluate it between the, you write when you are doing definite integral, you don't worry about the constant. You don't write the constant, right? 0 to 1. So
Yes,
this
sir.
becomes half sine inverse 1 whole square. Put 1 first and then put 0 minus half sine inverse 0 square. And sine inverse 1 is how much? What value of sine theta is 1? It is pi by 2, right? And sine
Yes, sir.
inverse 0 is 0. This is minus 0. So this, what is the value here? Pi square by 8 we are getting, right? The answer is pi square by 8. But the
Yes, sir.
problem is in this method that we have evaluated it as an indefinite integral here, and then we have evaluated it as a definite integral here. Now in such a case, when you are changing the variable, okay, the in case of change of variable, if you want to use a fundamental theorem, it becomes a little long. In this case, what we do here is when we are changing the variable, we convert the limits also. So same thing I'm going to do by change of variable method. Now look at this method. This is the method that you need to, this is a new method, change of variable method. Same integral we are going to do by change of variable method. Okay, we start by saying let I is equal to integral 0 to 1 sine inverse x by root 1 minus x square dx. Okay, this is
Okay, sir.
was the given integral. Now here again what we do is we substitute. Let t is equal to sine inverse x. Okay, so what happens? Dt dx becomes 1 by root 1 minus x square. That means dt becomes dx by root 1 minus x square. Now this step, till this step is the same as your earlier one. Okay, now the comes the
Yes,
something
sir.
new. Now see, we have changed the variable from x to t, right? That means these limits that are there, this limit, the lower limit and the upper limit, these also will change. How it will change? See, now for this value of x is equal to 0, right? So for x
Yes,
is
sir.
equal to 0, t is equal to, what is the value of t for x is equal to 0? Sine inverse 0. That means 0. For, now this is the upper limit. This is x is equal to 1. For x is equal to 1, t is equal to sine inverse 1. Sine inverse 1 is pi by 2. Okay. So therefore, now we rewrite the integral in terms of t. So we write integral. Now dx by 1 by root 1 minus x square becomes dt, and t is equal to sine inverse x, we have taken t dt. But the problem here is that we cannot write these limits 0 to 1. Why we cannot write these limits? Because we have changed the variable. And when we change the variable, the value of t has also changed. For x is equal to 0, how much is the value of t we are getting?
Yes.
0. So we give the lower limit 0.
0.
And for x is equal to 1, the upper limit, what is the value of t we are getting? Pi by 2. So we change the upper limit to pi by 2. That's it. Now we
Yes,
use the fundamental theorem. So this is half of t square evaluated between the limits 0 to pi by 2. This is half t square evaluated between the limits 0 to pi by 2. So this is half of pi by 2 square, okay, minus 0 square. So this is half pi by 2 square, which is pi square by 8, right? So now you see that we have saved so much of
yes, sir.
labor here. That is, in the earlier method, we were evaluating it as an indefinite integral first, right? And then we were applying the definite integral. But in change of variable, we have changed the variable, and along with that, we have changed the limits also. The limits change when the variable change from x to t. The variable change from the limits. The when the variable change from x to t, the limits change from 0 to 1 to 0 to pi by 2. This is the change of variable method. Okay, we'll do two problems more on change of variable method, just for practice sake and for understanding sake, and then we'll move on to the properties of definite integrals. Okay, let us see this problem. Problem is, evaluate. Govinda, are you listening or are you out? 0 to half dx by 1 minus 2x square root 1 minus x square. Okay, how do you evaluate this integral? Any idea? Any idea how to evaluate this integral? No, normal indefinite integral. How to evaluate? Don't look at the limits right now. If you see under bracket, under a radical sign, you have 1 minus x square. So this gives you a hint
Yes, sir.
that you have to put x is equal to sine theta or cos theta. So I start by saying let I is equal to integral 0 to half dx by 1 minus 2x square root 1 minus x square. Okay. Now what you do here is let x is equal to, you put sine theta. That means what is dx d theta? It is cos theta. That means what is dx? Dx becomes cos theta
Yes,
d theta, right? Now you put it in the, now one more thing is there, that we have changed the variable from x to theta. That means the limits must also change. What is the lower limit here? X is equal to 0. So for x is equal to 0, you have 0 is equal to sine theta, right?
yes, sir.
That means theta must be equal to sine inverse 0. And what is sine inverse 0? 0. For x is equal to half. Now we consider the upper limit. X is equal to half. For x is equal to half, half is equal to sine theta. That means theta is equal to sine inverse half. And what is the value of sine inverse half? What is the value of sine inverse half? Pi by 6.
The Sin
Right?
of 5/6.
Pi by 6, 30 degree.
Yes, sir.
Pi by 6. So now what does the integral become? Therefore, I is equal to integral. Now write the new limits. The lower limit now becomes 0. And the upper limit now becomes pi by 6. Now you change the variable here also. Now you see dx is what? Dx is cos theta d theta. So you put cos theta d theta divided by root over 1 minus 2 sine square theta into root over of 1 minus sine square theta. Right? This is the new, this is the,
Yes, sir.
uh, after changing the variable, this is what we are going to get. Now let us simplify. Integral 0 to pi by 6 cos theta by root over 1 minus 2 sine square theta is how much? 1 minus sine square theta is how much? This is, there is not a, there is no radical here. Why am I putting a radical? There is no radical here, isn't it? Is there a radical here in the question? 1 minus
Yes,
2x
sir.
square, is it under radical? No.
No, sir.
So it is not under radical. The radical was a mistake. So 1 minus 2 sine square theta into this. Now 1 minus 2 sine square theta, if you remember from multiple angle formula, is cos 2 theta. And root 1 minus sine square theta is cos theta. Right? D theta. Now what happens?
Yes,
This
sir.
cos theta cancels out. So what you're getting only 1 by integral 0 to pi by 6, 1 by cos 2 theta. And what is cos 2 theta? Cos theta is sec 2 theta, isn't it? And what is the integral of sec 2
Yes,
theta?
sir.
What is the integral of sec theta? Do you remember the standard integral for sec theta?
1 second. Sir, it was 1 lakh.
Is equal to
Sir,
वो लोग ऐसा
cosec
प्रैक्टिस
theta.
करते थे कि उस टाइप कुछ आता था
half
तुम लोग को
log tan pi by 4. It was in fact log tan pi by 4, not half, log tan pi by 4 plus theta. This was the integral, if you remember.
Yes, sir.
And not only that, but divided by the derivative of 2 theta, which is 2 plus. Now you don't need to give a c here because this is your definite integrals, right? That means this needs to be evaluated
Yes,
between what limits? 0 to pi by 6,
pi by
right?
6.
So now we evaluate this, take half outside, it will be easier to evaluate. Log tan pi by 4 plus theta evaluated between 0 to pi by 6, which is equal to half of log tan pi by 4 plus pi by 6, right? Put the upper limit first, right? Minus log tan pi by 4 plus 0. It is putting the lower limits, right? So what are you going to get? Half log tan pi by 4 plus pi by 6. If you take the LCM, you will get this as 5 pi by 12
5 by 12.
minus log tan pi by 4. Now what is pi by 4? It is 1. Tan pi by 4 is 1, right? So log tan
Yes,
5 pi by 12 minus log tan log 1. And you know log 1 is 0, isn't it?
yes, sir. Yes, sir.
So this is half log tan 5 pi by 12 only. But again, 5 pi by 12 can further be broken into smaller angles, right? This is a associated angle, right? So half
Yes, sir.
log tan. Now 5 pi by 12 can be written as uh, 2 pi minus pi by 2. 2 pi plus pi by 2. Can it be written or not?
Yes, sir.
So how much is this? 5 pi by 12. Oh, 5 pi by 12, not 2. It's 5 pi by 12, not 2. Okay. So now 5 pi by 12, how can you break it? No, 5 pi by 12 cannot be broken further. But what
Yes,
you
sir.
can do is pi by 12 is, you can convert it to degrees. 5 into pi is 180 divided by 12. Okay, and then try to calculate this. 12 1 and this is 12 5. So half log tan 75 degree. And tan 75 degree, you know what tan 75 degree is? Half log
Half.
tan. How do you calculate 75 degree?
75 days.
Sin 75 by
90
cos
minus 75.
75. No, but then that will
Oh,
give you
fine.
cot. That will give you cot. Sin 75 degree
Yes,
by cos 75 degree. Right?
yes,
And
sir.
What is sine 75 degrees? Sine 75 degree is the same as cos 90 minus 75, right? And this is the same as sine 90 degree minus 75 degree, right? And if you remember in class
Yes, sir.
11, I had told you that you should remember sine 15 and cos 15. You see, you are getting sine cos 15 by sine 15. Okay. So if you put the values for sine 15 and cos 15, ultimately what you are going to get here is log of 2 plus root 3. Okay. So you know sine 15 and cos 15. You know how to find out the value of sine 15 and cos 15. Sine 15. Remember, once again, class 11. Sine 15 is equal to sine 60 minus 45. Right?
Yes, sir.
Sine A cos B minus cos A sine B. Right? So this is sine 60 root 3 by 2. Cos 45 is 1 by root 2. Root 3 by 2 into 1 by root 2. Okay. Minus cos 60 is half. And sine 15 again is not sine 15, sine 45. Sine 45. And sine 45 is 1 by root 2. So what is the value? Root 3 minus 1 by 2 root 2. And similarly, you can find out cos 15 and you can put it here if you can't remember. Okay. So this is what?
Okay, sir.
मुझे बता हुआ क्या ये बता मुझे
So let us do the next question. Evaluate. Integral sin inverse 2x by 1 plus x square dx. Evaluated between 0 to 1. Now, can you tell me how to evaluate this? Should I evaluate this as an indefinite integral or should I change the
queen
limit?
of a differentiate हाँ ये बोला है
Sir, definite
Sir, ये बोला
integrals.
है कि a से पहले निकलेगा
We will change the
ये तो
variable.
नहीं बोला है ना ये तो नहीं बोला कि a से पहले निकलना होगा फिर
Okay,
queen
sir.
यहाँ पे बोला है एक a होना चाहिए एक होना चाहिए queen of differentiate यहाँ पे क्वेश्चन में क्या तेरे को मतलब question
Sin inverse 2x by 1 plus x square evaluated between the limit 0 to 1. We'll use change of variable here. Okay. We'll use and then use the fundamental theorem. We'll not first evaluate it as the indefinite integral and then as a definite integral. We'll change the variable. Okay. So what is the kind of substitution that is required here? Can you tell me, Amir?
Yes, sir.
What is the
Yes, sir.
substitution? What is the substitution?
पहला केस क्या बनेगा ये तो
Sir,
केस निकला और queen होगी differentiate
1 plus,
क्या होगा बता
sir, 1 plus 2x, when we will differentiate, we will get the 2x.
प्रोबेबिलिटी का एस कुछ बोला है कि रेड होना चाहिए ब्लैक होना चाहिए कुछ नहीं बोला है एस का प्रोबेबिलिटी बता कितना होगा 4 by
Let x
52
is equal to.
X is equal to 1 plus x square.
Stop your audio, Govinda.
ठीक है
Mute your audio.
Sir, the teacher.
Good, you are taking tuition for math. Let x is equal to tan theta. Okay. Because why tan theta? Because sine 2 theta is equal to 2 tan theta by 1 plus tan square theta. Okay. That is why. So therefore, when we put x is equal to tan theta, the limits also change. For the lower limit, for x is equal to 0, for this limit, what happens? 0 is equal to tan theta. That means theta is equal to tan inverse 0. And tan inverse 0 is 0. So the lower limit after the change of variable, the lower limit is 0. For x is equal to 1.
Yes.
For x is equal to 1, 1 is equal to tan theta. That means theta is equal to tan inverse 1. Which is, and what is the value of tan inverse 1? What is the value of tan inverse 1? It is pi by 4. So therefore, what does I become?
Yes, sir.
I is equal to integral 0 to pi by 4 sin inverse 2 tan theta by 1 plus tan square theta. And we are forgetting one more thing. What are we forgetting? We are forgetting to differentiate x. Dx d theta is sec square theta. That means dx is sec square theta d theta. Okay, so you put instead of dx, you put sec square theta d theta. Now all the variable and the limits have changed. This now becomes integral 0 to pi by 4 sin inverse 2 tan theta by 1 plus tan square theta is sin 2 theta. Okay, into sec square theta d theta. Okay, so
Okay, sir.
next one, integral 0 to pi by 4 sin inverse sin 2 theta is simply 2 theta. 2 theta sec square theta d theta. Right, now how do I evaluate this?
Yes, sir.
Theta, you can take 2 outside. 2 integral 0 to pi by 4 theta sec square theta d theta. Now if you remember, theta sec square theta is something that we have done in what? By parts, x sec square x, remember? So we integrate this by parts. How do we integrate this by
Yes, sir.
parts? First function is theta. This is
Theta.
algebraic and this is algebraic and trigonometric function. So we take the algebraic function as the first function minus integral of, we will not put the limits here. Okay, you see what we are integrating this as in by parts only. Limits we'll put, see after what I do, then you will put the limits. Minus integral of dd theta of theta into integral sec square theta d theta. Whole thing integrated with respect to theta, and this has to be evaluated between the limit 0 to pi by 4.
Pi by
Now we shall
4.
do this. Now we shall do this, that is twice theta sec square. What is the integration of sec square theta? It is tan theta. So this becomes theta tan theta minus integral dd theta. This is 1 and on this becomes only tan theta d theta. This has to be evaluated between the limit 0 to pi by 4. That means twice theta tan theta minus integral tan theta is log sec theta. Right? And this has to be evaluated between the limit 0 to pi by 4. Means twice. Now put the upper limit first. Pi by 4 tan pi by 4 minus log sec pi by 4. Right? After putting the
Yes,
upper
sir.
limit. Now put the lower limit minus the lower limit. That is lower limit is 0. That means 0 tan 0 minus log sec 0. So everything becomes 0 here. Right?
Yes, sir.
So what are you left with only? You are left with only twice pi by 4 tan pi by 4 minus log sec pi by 4. That is what you are left with. Now you simplify this, you'll get twice pi by 4 tan pi by 4 is 1 minus log sec pi by 4. Log, change sec to cos, 1 by cos pi by 4.
Okay, sir.
Twice pi by 4 minus, now what is cos pi by 4? Cos pi by 4 is how much? Cos 45 is 1 by root 2.
Yes, sir.
I get this as twice
Agi-
pi by 4 minus log root 2. So this is twice pi by 4 minus log root 2 can be written as half log 2, right? Because 2 to the power of half, root 2 is 2 to the power of half. Therefore, log root 2 can be written as half log 2. Now you multiply throughout, you get pi by 2 minus log 2. That's it. That is the answer. Understood? So go
Yes,
through
sir.
these.